Okay, recap what is the important part for this periodic table of element. So this one will help you to draw the uh, electron configuration, right? So make sure you have all this information on your revision sheet, right? So electron configuration. So you have two types, right? One you have the box one. Another one is the SPDF configuration. Okay. So you have the family 1, 2. The column one is column 1, 2, 3, 4, 5, 6, and then 8. Right. Now normally on the left hand side, uh, they are willing to donate electron because they have a few members outside their orbit. And for the member 7 and 6 and 7, they are more willing to pull other electron to join them. So when you have this behavior, family 1 and 2, when they are more willing to let go, they become tendency to become positive, right? So positive charge, they are called cation. Negative charge, they are called anion. Okay. So it's important you identify which one is which one. So if the answer, if your the question might ask you to calculate the amount of cation and anion after the chemical reaction. So make sure you write the correct equation. Okay. So far, any question for the periodic table? Oh, okay. Okay. So again, you can replace the front electron configuration with the N element at number 8 here. Okay, you can replace with helium, nickel, Ar, Kr, Xe, or Rn. Okay, so this is important. Okay, we already done with the behavior of the size of the electron, metallic, and all these. Okay, electron affiliation and all this. So this one by now you should be able to explain based on periodic table. Okay. We're a bit behind. We should be going into chapter 3 already. So our objective today is to complete our chapter 2, and then we go into chapter 3. Okay. Now today we go into primary bond and secondary bond. Okay. So what I mean by primary bond? Primary bond, they make the atom become stable. Okay, they make the atom become stable, and they are the one who affect the properties of the material, where they will tell you how strong is the material. So if they later I'll show you, and then there are three possible primary bonding. So metal plus the non-metal, 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 and then metals. Okay, so primary bond, they will affect the mechanical properties, mechanical properties of the material. So today, the main thing is, you know that primary bond, you have three types of primary bond: metal, metal, non-metal, non-metal, and the combination of metal and non-metals, right? Because the previous class from the periodic table, you already know which one is metal, which one is non-metal. So by looking at the periodic table itself, you already can know if the question asks you A plus B and the element of A, element B is extract from the periodic table, you should be able to tell which type of the primary bond can be formed. It's either one of these. right? It's either metal, metals, non-metal, non-metal, or metal, non-metals. This one, metal, non-metal, normally you take family 1 and 2 plus family 6 and 7. You get this one. Okay. This one, non-metal, non-metal, for example, carbon, C square, right? Or C sub, right? So means family 4 plus family 4, right? And so on. Metal, metal, for example, ferrum 3, ferrum 2. Okay. Okay. Next one, the first one is a primary bond. Okay, they are more stable states. Then the next one is the ionic bonding. Okay, inside the primary bond means metal metal ionic bonding. Ionic bonding is metal plus non-metal. You form ionic bonding. Okay, so means metals on this periodic table already have the colors. So it tell you which one is metal, which one is non-metals. So the first primary bond, first type is metal plus non-metal. You get ionic bonding. Okay, ionic bonding it means you take the metals color on the periodic table plus the non-metal, you get ionic bonding. Okay, so the first thing you identify is by their electronegativities, last difference of electronegativities. So usually I highlight on the diagram here. So on the left you have family 1 and 2. Family 1 and 2 because they have 1 electron outside and 2 electron outside, so they are more willing to let go of their outside electron at the outer orbit. Then family 6 and 7, they are more willing to accept electron from outside, right? So this 1 and 2, 5 and 6 and 7, they are very good friends. They always like to bond, become a primary bond, ionic bonding. Okay. Okay. So we did know in the previous lecture, we did introduce you what is reactive metal, what is reactive non-metals. Okay. Okay. So let's see what happened in the electronic and size consideration in ionic bonding. So let's say we take metals Li. So Li is over here. Okay. Column 1, row number 2. Okay. With electronegativity of 1 and non-metal F, which is here, group 7, with electronegativity of 4. So how do you get this number? How you get this electronegativity 1 and electronegative 4? You get from a table that we cover in the previous lecture. There is a table of electronegativity. Okay, you go to that table, there is a number there. You just copy that number. Okay. So you know this lithium Li is from group 1. So group 1, it will like to donate electron. So when it donate, it become cation, Li plus. Okay, so ferrum also same. Ferrum, they like to receive electron. So this is family 7. So they already have 7 members outside. He receive 1 more to become stable. So they will become F negative. So become F negative. So let's look at the first one first. So lithium Li, when it let go, lithium radius decrease from 0.157 to 0.60. Okay, actually is is decreased. So when it let go of 1 electron, why the radius decrease? Okay, what outer cell not there, then what happened? Okay, so again, when this one got 2 lah. Okay, you know how to write the SPDF already. So when this one let go, so Li become positive. And just now what you say? Yes. So loses 1, but the positive charges still remain. So more positive is is there, and you only have 2 negative charge. So it's like a magnetic. So more forces pull the electron inside. So that's why the radius become decrease. Okay, this is how you explain why the radius decrease. So from 0.157 nanometer to 0.06 nanometer because of the pulling force of the positive charge from the proton charge, okay, from the nucleus. So with the same understanding, what happened to the F? What happened to the radius? Increases because they accept one more member, and the pulling force actually unable to hold the electron. So it become increase. So after ionization, frontier, and so on. So this is just a chemical explanation where they cover in the previous lecture. Okay, so why this happened? Because ionization means release electron. The outer electron no longer in N2 but in N1, in N1 state. So then balance between the positive nucleus and so on. So the stronger force pulling the electron inside. Okay. So this one will be the maybe the part B or part C kind of question. It asks you, hey, why suddenly there is a decrease of radius in the for the bonding. Okay. Right. Okay, the rest you read lah. Okay. So when the process completed the structure and it take the structure of noble gas He. Okay, it take the form of noble gas He. Why? Because if it's here, you have 3 electron on the orbit. It contribute 1. You only have 2. So it reduced from here to here. Okay, here to here. So we take the form of noble gas He, but with the positive charge. Right. Same with the forum F. Right. So it increased, and the same explanation is an invert of what happened to the Li just now, right? So it take the form of Ne. It jump to the form of noble gas Ne. Okay. Okay. Now ionic bonding between Li and ferrum can be represented by these 3 types of presentation. It can be electron configuration, orbital diagram, and electron dot format. So the electron dot format is what you use in the lower level of chemistry class. Means you study in your SPM or secondary school chemistry. You see this one, right? You present this one as your answer. But in our class, you need to know another 2 more presentation, which is electron configuration. This one you get from the periodic table with the small numbers that we present you before we start the class. So, and then orbital diagram. So same, what you do is you write the electron configuration Li 1s2, 2s1 from the periodic table, right? And plus ferrum. So ferrum have this one, right? So if you don't know how to read this one, you need to go back to the video. And again, our video, I discovered that there's no picture inside the video. So what you can do, you go to the YouTube channel, you go to other last semester material engineering. You go to other semester and then you go and open the video for the explanation. Okay, it's the same material. Okay, only different semester. So same, you draw an arrow, transfer, ionization happen, put to here. So lithium become 1s2 plus ferrum negative, this one lithium positive, F negative, this one becomes 6. So this is how you explain ionization happen. This is how you explain how ionic bonding happen. You explain using equation. You don't even need to explain by words. You write this equation. Okay, if the question asks you to explain using orbital diagram, then this is the form lah. Okay. Only thing that I need to highlight here is the left-hand side is pointing up, right-hand side arrow is pointing down, and you always fill in the left-hand side first before you go to the right-hand side. Okay. Same with this one. When you throw away electron or ionization happen, you throw the outside remaining one first to another one. So this one, you should have no issue understanding this one. Right? Any question on this one? No, All right. Okay. Another example, NaCl, which is also popular. Sodium chloride, NaCl. So if you look at this one, are you able to draw draw the electron configuration, orbital diagram, and the electron dot format for NaCl? Okay. So are you able to draw? You are combining NaCl. How you draw? You know that you are combining NaCl. You want to get NaCl. How the primary bonding or ionate bonding happen? Na plus Cl. So Na is what? What? S P. Copy it out. 1s 2, 2s 2, 2s 1. Okay, what? Correct not? Oh, Na. Sorry. 2s 2. Sorry. Straight away take Ne and 3s1 plus Cl. Here's here. So Ne 3s2 plus Sp. This is what? S, this one? Forget already. And this one is D4, D5, D6, D. So on. Okay. Okay. So you have this one. Go back to the diagram. Oops. Okay. So Cl is what? E 1, 2, 3, 4, 5, 6, 7. Okay. So equal Na plus Cl. Ionization, you must draw the arrow. So Na become in the form of Na and negative. Sorry, not negative, positive. Or Na positive, right? Na positive. And this one, negative, you take can be AT, AR, sorry. Okay. Of course, you can write that one, or you can write a long answer. Okay. The rest you read. I actually already explained on the whiteboard. Anything you need me to do? This is just an illustration. So Na is a small atoms. Cl is a bigger atoms. Okay. So we already explained the size of the atoms relatively to their charges, right? So here to here, same row, but here the atom is small. But as you move towards right, atom become bigger. Okay. So that's why we have this one, and then Cl become the form identical to argon. Okay. And so there are three forms of presentation. I'm drawing the first presentation only. The last two, I think you're able to change it. Just need to be careful on the arrow that you draw for the box presentation. Make sense? Make sense, All right, next we go to force already. Now, as you can see on the table here, y-axis is the force, and you have a neutral point, positive force, negative force, and you have the distance, x-axis is your distance. So let's say you have two atoms, let's say NaCl, right? Let's say NaCl, Na small, Cl big. So you have reference point from the nucleus. Nucleus to nucleus, you have the initial length, or you call it radius, not radius, diameter, A0. Okay. So R, small r is a cation, positive. Big R is for anion, negative charge. So A0, A sub is your take R plus big R. Okay, make sense? So this is the first equation before you derive further. This one you should know. Okay. So in the question, normally it will give you, like, for example, Na, radius, it will give you radius of Na equal one number, radius of Cl equal one number in nanometer. So the next one, you need to find the A0, which is R plus big R. This is R, this is big R, right? Okay. Okay, the rest you read. What is important is the two blue line over here. So if you move the atoms further away from the cation, positive charge, there is an attractive force will be reduced, and as you move, if you move nearer inside, you like a magnet kind of effect, the repulsive force increase and then fade off. Okay. So yeah, so this is the explanation. This one you can read. So there is a net force when bond is formed, which is here. So you combine the attractive and repulsive, you get the middle point here, net force. Right. This is the black line means the black line here. Okay. So it becomes closer and repulsive is formed. So the rest we are. So what is important here? There is an equilibrium distance that reach when the bond is formed. There is like a balance distance when positive charge, negative charge when they form and become stable. There is A sub 0. There is equivalent distance. It will be formed. Okay. So what is important is this equation lah. AO plus R plus small r plus big R. Okay. So from here, we introduce you a very basic equation F net of force equal to Annian force plus attractive force plus repulsive force. Okay, so this is the first equation to calculate the force between the two to form the ionic bonding. So this equation for ionic bonding. So when a bond is formed, the net force is 0. So don't try and go and figure out what number. When you have an equilibrium or the ionic bonding becomes stable, the net force is 0. So you don't need to go and scratch your head and fill in any numbers. Of course, you will see some confusing statement inside the question. You'll try to confuse you, give you some false number here. Okay. So don't confuse with the net force. Once it becomes stable, the net force is 0. Then it will ask you to find the force of attractive or repulsive. Okay. How to find the net force? There's an equation there. This equation here. So the front one is attractive energy. Okay. This equation won't be given in the test. You need to memorize. And this equation come out every test 1 question. Every test 1 question, I will show out this equation. So don't say I don't tell you. They sure got 1 question ask you to use this equation. And I won't give this equation in the test question paper. You need to memorize this one. Okay, so there are this equation. The front one is attractive energy. This is for the attractive force. And then the last one is because of the repulsive energy. Okay. So what is A and B? B and N. B is a constant value, will be given in the question. N also will be given in the question. So this number, you see the question give you N equal what, B equal what. It means that it asks you to calculate this F net. E is the electron charge. We already covered this one in the previous section. I give you the E charges already, 1.6 something. Z1, Z2, this one you need to read from the periodic table. Z1, Z2, their number of electrons removed or added to the atoms. For example, NaCl, your Z1 is 1, Cl is 1. Right? You add 1 electron, and you release 1 electron and receive 1 electron. Okay, it depends on, but even you flip the 2 things, you still get the same answer. As long as you understand like how many electron was transferred. Because you are dealing with the stable states. Stable state means you reach a stable condition. There's no extra electron appeared at the products there. Okay. So here again, they must have positive signs. They must have positive signs. It means for cation, you have positive number. Z, you have a negative number. So negative, negative, you negative sign here. Yeah. So just remember here, this one is a trick here. So this, I highlight this one, they must have positive sign. One positive, one negative. One positive, one negative. So when you multiply, you get negative value, multiplied by negative. This one become positive value. Okay. So EO is a primitivity of space, also constant number. A new number, this one, 8.85, 10 power negative 12 Coulomb over Newton dot meter square. Okay, so sometimes we do give you this number. Okay, sometimes we do give you this number. So important is you know this equation. Okay, we'll give you this number, n equal what, b equal what. Then you know this equation is you need to apply already. Okay. The rest is substitution. Okay, so this is another one. So this is the very simple case. So what happens if you see another case? So and okay, what is the difference between this diagram and this diagram? This is force. This is energy. Don't confuse this diagram. This is force diagram, and this is energy diagram. There's a typo error on this slide. It's attractive force. Attractive force, not energy. This red color is typo error. This is force. This is force. Okay. And then second diagram, this one is on energy. It's a flip of what you see in the force. So the concept still the same. All right. Why? Because if you release electron, means your energy drop. Same things. You just flip the thing. So you have another equation with this energy. E net equal positive something plus something. The front one is the same form. Only the sign, the back one is different. What is different is the sign. Force in front is positive. Behind also negative. The force one is negative, negative. The force equation negative, negative. But for energy, you get positive, positive sign. Don't confuse between these two signs. Then this is correct. Attractive energy. Previous PowerPoint slide is wrong because it should be attractive force and repulsive force. So it's just typo error. So again, when the bond is stable or form, energy will be 0. Wrong typing here. It's not net force. It should be net energy. Because this is net energy. So the energy will become minimum. Minimum. Sorry, not 0. It should be a minimum energy was formed. Okay. So it means the value given in the question, when you see E minimum, it means the stable bonding is formed. So you use this energy on the left-hand side. Yeah. Okay. So there's a tutorial question. The rest you read. As you read. So I give you the two slides. I'll give you the 2 slides. So integration. Here, if you compare the two, the left-hand side is force diagram. The right-hand side is energy diagram. Energy is force multiplied by radius. Energy is force multiplied by radius. So if you integrate force dr, what does it mean? It means area under the graph. Area under the graph. You take force multiplied by the area under the graph, you get the energy. Okay. So then you take this one, energy equal to infinity to R. Infinity means outside the outer orbit. You can be infinity until you become so close with the R. Okay. So here you have two forces, attractive and repulsive. So you break this net force into attractive and repulsive energy. Right. So you can write in the form of EA and ER. It makes sense, huh? Okay, let's look at how we apply these two. So we have E equal to integrate F dr. This one, it can be Fn equal Fr plus Fa. Okay. Let's look at this example. So let's say you have magnesium and S. So magnesium 2 plus, S 2 negative ion. If the attractive force is given at equilibrium, so attractive force is given, calculate responding distance. If S negative has radius, so and so, calculate the radius of another one. Repulsive force between the two ions at this position. So basically, it's an application of this equation, right? Fn equal to Fa Fr, and what is the equation of this one? Application of this one, and the energy, not energy. Here is not the energy, so this one do not apply. So it just asks you to apply the first equation, the force equation. So responding distance, how you do? So first, is the value of FO, AO, right? So you need to calculate the things. So this is actually a column law, right? Column law, because you deal with electron. So F net equal to minus, force is minus, minus, energy is positive, positive. So minus Z1, Z2, E2, 4 pi epsilon A2, and so on. So what value you know? You know Z1, Z2, because from the equation here. Okay. And what else? A and B is not given, so you calculate the first one. So at this question, so we look at the actually it's not, it is given but this just means that we look at the first component first Okay, we look at the component first. It's not really it's not given actually is you can calculate this one. So for here we are calculating the first again there's a typo error here, is the attractive force, not energy. It's attractive force. The last one also repulsive force and not energy. Typo error. Okay, so there is a calculation that you can calculate. Why? Because okay, so from here, F attractive equal to this equation, right? So you rearrange this equation because you want to get the A. You want to get the A, right? So you rearrange, become square root of something over something. Okay. Important you understand the why we do certain steps. We write this. The first one is attractive force. Then we rearrange. Okay. Because we are given attractive force. That's why we do this one. Then we substitute . Okay, substitute. So Z1 is positive 2 because it's involved with 2 positive. Z2 is 2 negative because 2 negative here. So just this is the careless mistakes usually apply we see in the test, right? So you confuse with which one is positive, which one is negative. Okay. You just see the symbol, the end products. Is it positive, then you write positive. If it's negative, then you write negative. Okay, the rest you substitute. This one already covered. 1.6 10 power 19 column. This one standard value. We expect you to memorize this value. No, you'll be like gravity value. We won't give you, right? So you have to memorize lots of things. Unless the equation is very complex, then we will give you. This one. This one. Yeah, correct. Normally we will give you epsilon. Normally. Don't give, then you blank lor. You only leave, you give this one, you give the general, then memorize the standard value lah. This is the part where we give you marks actually. You write this number, give you 1 mark here. If we give you, then there will more complex question coming in. If you give you all the numbers, means you need to explain things. Okay. But anyway, I'll give you, I will brief you when it comes to test, whether it's given or not given. Okay. So basically, E, you know, this epsilon, you also know F attraction given by the question. So you have all the value, Z1, Z2, E, pi, you know lah. This one, F attraction also know. So you have all the values, substitute in, press calculator, square root. Okay, that's why when you substitute this value, this one become positive. That's why, because you cannot square root negative number. If you press square root negative number, you get error in your calculator. So if you get an error in your calculator, means something wrong with your Z value. You know already lah. So it should be positive value in the square root here. Okay. You substitute, you get a number. This is a reference number for you, 2 point something, 10 power negative 10. Okay, so first step is to take the force equation, substitute accordingly. So Z value, how you get it is from the formula. Okay, then you substitute accordingly. Once you get it, you change it into nanometer. Okay, 0.249 nanometer. So this become -9. This one move to the front. Actually, there's a typo error. So when you do revision later, just take note this one is -8, not 9. Okay, so but what is important, you understand the steps, all right? The procedure we do to solve this kind of question. Okay. Okay. Then any question for the first one? No, it's just substitution and okay, the second one, S2 radius is given. Calculate unit radius for M2 because you already have this one. So A naught is what? A naught equal to R plus big R, small r plus big R. So you already have this. This is a big R. So this is AO. So you have less one value. It's a deduction kind of equation. So AO equal to R plus big R. So we want to find this one. This one was given. This one you calculate in section A. You find the missing value. At the end, you get 0.06 nanometer for magnesium. Okay. Nothing complex here lah. Okay. The third one, repulsive force. So repulsive force, you know that this is attractive force. This is a repulsive force. You already have this one. You have then you have this one. So A you have, R you have. So you calculate the value first lah. You calculate the value first. You calculate a value for B in the equation. So when it's stable, F net 0. Of course, this one won't be given, but automatically we assume you know that when it comes to a stable, F net is 0. This one you already calculate just now. Not calculate, but given. So even section A, you don't know how to calculate. Sometimes the question give you the answer for the another section. So we did give you a chance to answer. Not that it was snowball. Sometimes you like, for example, this section C. This value, although you're not calculating the numbers, it already given you in the question. Okay, so you find the missing value here. Okay, repulsive force. So at the end, repulsive force will be same lah, negative something. Because you move this one to the left, positive value, but there's a negative sign there. Move the negative sign to the left. So you know that this component is negative 1.49 10 negative 9. It's kind of tricky lah, this question. Actually, the value is from the question, but it changed side to positive to negative. Okay? Any question? Yeah, so let's look at example 6. Now, this question asks you about energy, also application of question. So repulsive force is given, at equilibrium is given, repulsive is given, R is given for positive charge and negative charge ion. And this one are all in the nanometer. All right, this one is nanometer. Calculate the value constant B using the repulsive force energy equation, and the bonding energy E minimum, assume n equal to 9. You need to find E minimum. Basically, it's an application of this one. E net equal to plus something plus something. Okay. First is it give you repulsive force. Might ask you to do repulsive force. So you use the force equation, not the energy equation. Don't confuse. And force equation is negative, negative, and not positive. So it's negative, negative. So you have the repulsive force of this one, right? So again, typo error is not energy, it's force. So the A, you need the A value, right? A value equal to R plus big R. The front one is positive charge, the back one is a negative charge. So you're given in the question here, R was given. So you take these two numbers, you add them together, you get AO, which is this number, A here. Okay. And you can find the Z1, Z2, right, by given in the question. What is your value for Z1? Plus 1. Z2, negative 1. So you get the positive value here. Okay. So you get the AO, and then repulsive is this number. So repulsive force is negative. Right, repulsive force is this one. Repulsive force is this one, and this one is the let's see. Yeah, given the question. So this one repulsive. So you put inside there. N is 9. N is 9. So substitute here. A is here. Power n plus 1. N is 9. So this one is 10. So there's only one unknown, which is a B is missing. Rearrange the equation. You get B. Again, B is positive value. It's not negative value. Negative, negative, cancel. So you get this one. Oh, wrong. I think something wrong with my answer here. But the value is 8.9, 8.59 10 power. I think is you calculate lah. There's the number there. Right. There's the typo error in my answer. Okay. The value should not have something like that lah. It should be. Yeah, 100, because 10 is 100, and then multiply by 9. Yeah. Okay, you get the B. Then you move on to the energy. Energy is negative, negative sign. Negative, negative sign. You substitute the value, right? You have all this value. You have Z1, Z2, E, you already know. E epsilon 8 point something, E is 1.6 something. A, you calculate already. B, you already find just now. N was given, A was given, A was this one. Right. You substitute value, you get negative 7 point something Newton meter of Joule. Okay. So this application of equation. Okay. So nothing nothing complex. It's just the equation. Three equation. A equal to R, small r plus big R, and then this two equation here. All right. Yeah. Yeah. And then what is important is the periodic table. Any question? No, then we have a short break. Okay, we continue 11:05. 10 minutes breaks. Sign your attendance. Remember, sign your attendance. Huh?